Cool. Hi, folks, and thanks for coming to this talk. My name is Kevin Anderson. I'm a researcher at NREL in the Outdoor PV Performance and Reliability Group. And today I'll be talking about PVLib Python. So together with the other people listed on this slide from many different institutions, we are the core developers and maintainers of PVLib. Probably many of you are already familiar with it, but it's an open source PV system performance modeling package. So today I'll be talking a little bit about PVLib, but mostly about updates that we've made to the package since the last PVPMC workshop in 2019. And as you can see from the timeline there, we've released quite a few versions since then. So there's a lot to talk about. All right, so here's an outline of this talk. First, I'll just be giving a brief overview of what PVLib is for those who are not familiar with the specifics of it. Then I'll talk about what new models and new weather data sets that we have made possible to use with PVLib. I'll talk about some documentation updates. Good documentation is critical. I'll also talk about automated software testing, since I think we do it in a pretty good way. I'll talk about a few statistics that we have for community growth. It's generally hard for us to track that kind of thing, but we do have some numbers available. And finally, I'll wrap things up by talking about the future as we work towards an eventual PVLib 1.0 release. So probably many of you are already familiar with PVLib. If you'll indulge me, I might ask you guys to raise your hands if you or somebody you know uses PVLib in your work. Okay, so basically everybody. That's great to see. For those of you who haven't, probably you should be, but the one sentence description here is that it's a Python library for PV performance modeling that is community driven, free and open source, and well documented. And so it's kind of living in a similar world to tools like SAM and PVSYST, but it is also fairly different from those tools, as I'll talk a little bit more about in a minute. I think of PVLib as comprising three main sort of pillars or areas. The first is as a modeling toolbox. And so to go from weather to an AC power forecast for a full system model, the way that we do it is by modeling many different things and combining them into one sort of coherent end-to-end model. And so the modeling toolbox part of PVLib provides standalone and user accessible implementations of many models that are described in the scientific literature, doing each of these sort of topic focused modeling steps. So that's things like solar position and atmospheric modeling, irradiance transposition for both front side and rear side, cell and module temperature models, clear sky models, PV loss models like snow, soiling, shading, and reflections, generating IV curves, much more. And really, I view this as the sort of foundation of PVLib, where not only do we provide models in all of these modeling areas, but PVLib, the lib, if you pronounce it differently, it stands for library. And we provide, for example, a half a dozen different irradiance transposition models. And so it's really useful for not only doing end-to-end modeling, but also seeing how your answer changes when you switch to different models along the way. So this modeling toolbox is really flexible because you can use each of these models independently if you want to focus in on a specific effect rather than doing a complete system model. If you do want to do a complete system model, we can do that too. You can either chain each of these models together yourself, or you can use what we call a model chain, which does all of that for you. Basically, it's combining all of these individual steps together into a single coherent and conceptually correct workflow that does all the plumbing for connecting the outputs of one model to the inputs of the next. And I say it's completely scriptable and automatable by design here. What I mean by that is, one of the things that sets PVLib apart from SAM, PVSYST, other things like that, is that it doesn't have a normal point and click user interface. And in fact, the way that you use PVLib is through Python code, where PVLib is one of many hundreds or probably thousands of open source Python packages that you can just install into your own PVLib environment and import and use together. And so since you're interacting with PVLib through code already, it's not like you have a sort of scripting aspect bolted onto it after the fact or anything like that. It is scriptable by default inherently, which is really powerful because it means that you can iterate over different design variants or multiple weather files, switch out different transposition models and whatever else. It also means that you can use PVLib in tandem with all of these other packages, these third-party packages that I mentioned. And I'll throw out some buzzwords. You can do your machine learning with PVLib. You can do things like connect it up to databases or do really advanced plotting, numerical optimization, stuff like that. And I think that this is a big reason why we keep hearing PVLib being mentioned in talks today. It's because it's so flexible and allows you to do things that a lot of other modeling tools just don't really make accessible to the user. The third aspect here is data I/O. So in the PVLib.io tools module, we provide fetcher and importing routines for many different data, weather data formats and many different weather data providers. And we're adding more all the time. There's some listed here. If you check back next year, we'll probably have some more on that list. So this is just a brief summary slide. Of course, I have to skip 99% of the detail. If you're interested, I encourage you to go and look at our online documentation. It's at the bottom of the slides. Probably many of you can't see it, but if you just Google PVLib docs, it'll come right up. Okay, so now getting into the new models that we've added since the 2019 workshop. I'll just kind of go down the list here. We've added an implementation of another 2D view factors model for front and rear side irradiance, similar to a model used internally by DNV. We call it infinite sheds. We've added several new functions for reflection models for both direct and diffuse irradiance. A handful of new cell and module temperature models, including some notably that include thermal transients. And so if you're modeling at 1 minute or 5 minute scales, for example, the thermal inertia of your module starts to come into play, and the traditional steady state model doesn't really do that great of a job. So we have some new models there, which is really exciting. A new snow loss model and 2 soiling loss models, both kind of based on the concept of accumulating and then a cleaning event. We have a sky diffuse shading model that we've added. 3 new inverter functions, which are interesting. One for extracting inverter model parameters from measured efficiency curves. But the second 2, I think, are really cool. They are extensions to previously published models to, in a conceptually coherent way, extend them for multiple MPPT inputs. And this was, I'll talk about that more in a second here. Cliff did that. A handful of single diode equation and single diode model fitting functions, which I'm not going to get into here because that's a whole rabbit hole like we just heard on the previous talk. And a Python implementation of the Spectral 2 spectral irradiance model for generating clear sky spectra curves with Python rather than calling out C. An implementation of the wavelet variability model, which was used in a few posters in the session today, as well as an extension to our single axis backtracking code to better handle cross-axis slopes. On the model chain side, so of course, many of these models that I just described are also accessible via the model chain. Another interesting extension that we've added to the model chain is the ability to model heterogeneous systems. So for example, subarrays pointing in different directions, but connected to the same inverter, and that's where the multiple MPPT inverter models come in. You can also have different subarray electrical properties, like different module types or different number of modules per string. Real life systems are messy, and so you got to model them that way too. So it's pretty exciting to have this. And a big part of this was contributed by Will Vining from Sandia, who I don't think is here today. But anyways, it's really great to have this in place. So thanks to Will. Another exciting big project that we completed was last summer in 2021 through the Google Summer of Code. And Adam Jensen, who we heard speak earlier today, contributed new functions to fetch and import weather data from several new providers, including the BSRN, that global ground station network, as well as several satellite-based and reanalysis-based data sets. MERA 2 and ERA 5 are pretty widely used in the global PV community, maybe not so much in North America. We do want to get those into PVLib eventually, but fetching that data is substantially more complicated than it is for several other providers. And so we're still chewing on how exactly we want to do that. But anyways, at some point in the future, we have to have those too. And I want to plug Google Summer of Code here. If you're not familiar, it's a little bit like a summer internship at an open source organization like PVLib, but there are many others also. We would love to do it again in the future. We had a great experience with Adam and would love to repeat it. So if you or somebody you know might be interested in that, it comes with a very small stipend from Google. But the real benefit is to work and to have a mentor like people on the PVLib team, which is priceless. Oh, and previously, if until recently you had to be a student to apply to Google Summer of Code, that is no more. Anybody can apply so long as you're a beginner at open source. Wrapping up the code changes here, we made the difficult decision to deprecate the PVLib.forecast module. So we're not going to be doing a whole lot of maintenance on it moving forward, and at some future release, it'll be removed entirely. We did some reorganization, whereas the PV system module was a little bit of a dumping grounds for anything related to PV modeling. We've split that out into more topic-focused modules just to make things a little bit easier to maintain and find as a user. We made some good consistency improvements, especially in the IO tools module regarding things like variable naming and what data structures we return. And so most of the IO tools functions now have the ability to map whatever, everybody calls the same quantities different things. And so now PVLib is smart enough to recognize those and map them into a nice standardized naming convention, which is very convenient. There's many other marvelous enhancements and bug fixes, which the slide is too small to contain, unfortunately. But all of the details are in our online documentation. We have very thorough sort of what's new notes for every version that we release. And so you can check out the full details there if you like. Moving on to documentation, this is something that I'm particularly excited about. We call it the example gallery. The idea is that it's kind of a cookbook of modeling recipes where you can say, man, I really wish I knew how to model solar position with PVLib. You can go and try to look at the function documentation. You can maybe go and look how somebody else has done it on Stack Overflow maybe. The idea here is that it's a small sort of self-contained bite-sized script that has, it achieves some kind of modeling task or simulation task using PVLib, and then it makes some kind of plot to summarize what you did. And the idea is that maybe it's not exactly what you want, but it acts as a building point. You copy and paste it into your own Python environment, and then you have a place to start from, but for building off your own code rather than having to start from scratch. So we have maybe 20 of these in the gallery so far, covering many different topics, and I certainly hope to add more in the future. I think these are pretty neat, especially look at the solar position diagram. That's pretty neat, isn't it? I like that a lot. I made that with PVLib. This is not necessarily new since the 2019 workshop, but it's really useful, and I want to point it out anyways. Every function in PVLib, which includes things like the model implementations, so the Ashray IAM model in this example, but also the model chain functions, the IO tools functions, all of these get their own documentation page with its own URL and with very detailed notes about many different things, including a description of what the function does. If it implements a model, it describes the model. It lists the inputs and outputs of the model, not only describing what they are, but including any kind of nuance that you need to understand to be able to use the model effectively and correctly. Things like what units things need to be in, what data types they're expected to be in. We also include links to the scientific references for the model. And so every model in PVLib is based on some paper somewhere. We link to that. We also link to any kind of review papers or validation papers that are also relevant. And finally, there's a lot of cross-linking in the PVLib documentation where we might link to other related functions that you might be interested in. For example, other IAM functions that you want to compare against, for example, as well as example gallery pages that use each function. So, as we're developers of PVLib, but we're also users of open source code in general. So we're very aware of how painful it can be when documentation is not very good for a package that you're trying to get started with. So documentation is definitely something that we try to take seriously and put a lot of effort into. This is something that we've only been doing for maybe the last year or so, is long form interactive tutorials at meetings like this one. Largely championed by Silvana. We did one at PVSC last year and another at a Python conference, PyData Global. And the idea is that, in the form of Jupyter notebooks, or we go from knowing very little about how to use PVLib to having a sort of a complete, basic but complete system performance model, all implemented using PVLib, and we do some auxiliary stuff using data manipulation and plotting packages also along the way. So the material for the two that we've already done, the PVSC and the PyData ones, it's all open source. It's available on GitHub if you want to go and look at that afterwards. That we're going to leave that up in perpetuity. We also even have a YouTube recording of the PyData Global one. They recorded that for us and put it on YouTube, which is nice. But we'll be doing another one here tomorrow afternoon at 4 or 5, sometime tomorrow afternoon anyways. So Silvana is going to be doing a lot of the presenting. I think some of us will be helping out there too. And several PVLib folks will just be floating around to help answer questions and help people get started. And so if you've been waiting for a good opportunity to dip your toes in the PVLib pool, this is probably it. Come check it out. It'll be a good time. I want to talk a little bit about automated testing now. Software testing in general is very important. We all want PVLib to be reliable and robust. We don't want it to be giving different answers depending on, because we didn't pay enough attention when we were implementing it. We don't want to be accidentally breaking things and not realizing it for 6 months. So we put a lot of effort into testing. We have over 10,000 lines of code. I went and looked for this conference, 10,000 lines of code just for testing alone. And we have cloud-based infrastructure set up to be automatically running these tests all the time. Every time we make a change, we rerun all the tests. We run it on different operating systems, on different Python versions. We try to be basically as thorough as we can to make sure that the software works as intended. And is covering nearly the entire package. Yeah, so correctness testing is very important. Something that we don't do quite as much of, but I think is really interesting and something I want to do more of in the future, in addition to testing for correctness, is also testing and monitoring the speed of PVLib over time. Since it's so scriptable and scalable, keeping PVLib fast is something we're very motivated to do. And so keeping track of execution speed over time is also something that we've been doing lately. And we use this this is useful in two ways. Number one, it identifies where the bottlenecks are in a PVLib model, and so we know where to go and focus our efforts to make things faster. Number two, it saves us from accidentally making slowdowns in the code when we go in and fix a bug or change something to something we think might be more efficient and doesn't actually turn out to be that way, because spoiler alert, computers are complicated. This is a pretty useful way to alert us that something slowed down that probably shouldn't have. All right, I want to talk about community growth. As an open source software package, we don't require registration or signups or anything like that. And so it's difficult to keep a finger on the pulse of our user base. And in fact, we don't really have a good sense for even what order of magnitude of people are using PVLib. We definitely know it's widely used. Our Journal of Open Source Software paper has been cited several hundreds of times by scientific researchers. And for sure, it's used extensively in industry also. But we do have a few metrics that we can track anyways. For example, our Google group, which is an online listserv or sort of user discussion forum, as of a couple of weeks ago, just crossed 650 members in it, which is about 4 times what it was in the 2019 workshop. And you can see the growth of that over time on this orange curve here. We've seen similar growth in the GitHub stars metric. GitHub is where we do all of our code development, and the star is kind of like GitHub's equivalent of a browser bookmark. It's a way of registering interest in a project over time. And we've seen very similar growth there, which is encouraging. Again, it's a little bit difficult to translate those numbers into, the overall number of users that we have. We don't really know what fractions those are of the total user base. Surely they're small fractions, or at least I hope they are. So I tend to focus more on the growth rates rather than the absolute numbers, at least for those two curves. What's more concrete, though, is that we have had to date contributions from over 80 unique individuals, which is just to put that in context, the core contributor group is only half a dozen people, which means that the vast majority of unique contributors are just community members that decided to get involved. They were interested and stepped up and joined in, which is really cool. And I've put all of their GitHub profile pictures here on this slide. You'll notice that many of them are humans. Some of them appear to be Space Invader type creatures. No, I'm just kidding. That's GitHub's default profile picture. But community contributions are really critical for open source projects to survive in the long run. And we can't do it alone. Eventually, we're going to get hit by a bus or have to switch over to wind or something else. Hopefully not in that order. And so it's really great to see the continued growth here. Again, we see this nice accelerating trend by the unique contributor count. So this is focused on code contributions. Of course, if you want to contribute code, we are more than happy to take it from you and get it merged into the main code base. But that's not the only way to contribute to a project. Even things like filing bug reports, making suggestions to improve our documentation or feature requests, things like that, are all really great ways to contribute to open source projects. And we definitely welcome that. I'm not exactly sure why this is, but even some of my good friends are nervous to file bug reports on PVLib because, well, I don't know, I won't try to speculate why, but the fact remains that they're nervous to do it and basically won't do it. They'll text me a bug report instead, and then I file it. I'm happy for the bug report. I would prefer that they file it themselves. So please know that all of us are very friendly. We try to be very welcoming and certainly want this number to continue growing. And so if you want your GitHub profile picture on here, at next year's presentation, feel free to join in and we'll help you get started if you like. All right, I want to wrap things up here talking about PVLib 1.0. We just released PVLib 0.9.2 even just a few days ago, and so you might think 1.0 is right around the corner. Probably not. 0.10 is coming next. We will release 1.0 when it's ready, rather than when we run out of fingers to count version numbers. Part of the reason that we're not rushing a 1.0 release is that when you hit 1.0, you're kind of supposed to stop breaking people's code by renaming functions or renaming variable names, things like that. And so all of the changes that we want to do to make things, completely consistent across the entire package, we're already pretty good about that, but there's still room to improve. Filling some modeling gaps, better documentation, things like that. We want to get that done before 1.0 because some of that we can't really do afterwards, at least without going to 2.0. So we have some ideas for the things that we want to do before then, but we would love to get feedback from you guys. Really, user feedback is also pretty scarce in the open source world. And so we have a users group meeting tomorrow before the tutorial. It's a separate session. And if you're interested, you can come to that and hear about the roadmap that we have suggested. But if you have your own ideas for what you'd like to see in PVLib, we'd definitely be interested to hear it. So please come by if you're interested. Anyways, that's it from me. Thanks very much, and I look forward to any questions.